Hi there and welcome. My name is Michael Kentenich and I'm a Microsoft Technical Trainer. In this video, you will learn why Azure Cosmos DB is perfect to unleash the power of your data. It is your one-stop solution for globally distributed multi-model database service. As an enterprise developer, you're no stranger to the complexities of data storage and retrieval. As a NoSQL database system, Azure Cosmos DB addresses several challenges that arise from the limitations of traditional relational databases. Global distribution is at the core of Azure Cosmos DB, whether your users are on Earth, Mars, or beyond. That's actually for a future release. No matter where your users are on planet Earth, this database ensures data availability across regions. Achieve low latency reads and writes by distributing data close to your users, adding regions in which your data needs to be available. 5 different consistency models adapt to your application's needs, and you pick what works best. Unlike traditional relational databases, Azure Cosmos DB embraces a multi-model approach. It accommodates documents, graphs, key value pairs, and column family structures. Developers can choose the right model for each use case. No more square pegs in round holes, just cosmic alignment. Guaranteed availability and SLA, service level agreements. Cosmic downtime, not on Azure Cosmos DB's watch. With 5 nines availability, your applications remain resilient even during asteroid showers or server failures. Comprehensive SLAs cover throughput, latency, consistency, and availability. Your mission-critical workloads stay on course. Need to handle data at planetary scale? Azure Cosmos DB scales horizontally. Add regions, partitions, and throughput without gravitational constraints. Let's identify the key benefits and components provided by Azure Cosmos DB. Azure Cosmos DB is a fully managed database service for NoSQL and relational data that supports modern app development such as artificial intelligence, digital commerce, Internet of Things, booking management, and other kinds of solutions. It provides fast performance, flexible scaling of throughput, and clear rules for data consistency and high availability. I would like to break down a few of these components and concepts to help you better understand what Cosmos DB offers. Fully managed, for example, means it is a platform as a service offering, where Microsoft takes care of the underlying infrastructure and you can focus on how to use Cosmos DB in your solution instead of patching servers. Let me show you a few things more on a whiteboard. I want to do comparison between the SQL, the so-called relational databases, and the NoSQL or non-relational databases. First of all, before we go there, let's just figure that NoSQL doesn't mean that Cosmos DB doesn't understand SQL, the structured query language that all database admins love, obviously. NoSQL stands actually for not only SQL, which just says that you can use SQL, you can even store relational data, but not in the same way that you use tables, rows, and columns in a relational database system. And that not only SQL stands just for the way that these non-relational databases like Cosmos DB handle the data. I would like to figure out what are the characteristics of both of these different systems and what kind of features or benefits do they have. So for this one, I would like to use my friend Copilot, and I will use a prompt in here where I say I'd like to compare relational with non-relational databases. What are the characteristics of relational databases? And that should give me a number of different sticky notes, some ideas, so that will be specific to relational databases. So in a relational database, we have a structured data storage. We have these tables, columns, rows. That is what we will call the relation model, relationships between these different tables. So you could have a customer, order, products table, and all these different tables have relationships between them, usually based on some sort of ID. So they could at some point also run a query where you get all the products that a specific customer bought. And that is where they get the name from. With these kind of databases, it's usually super important that these databases have not only strong consistency, so the data is not only always available, also always correct, meaning we always read the latest right. If we want to know what a customer has bought last or what we have in the warehouse inventory, we need to know that the numbers that are coming back are actually the correct ones. This is where it is super important to enforce that data integrity. With relational databases, there's this concept of ACID, the all or none methodology that's behind it, where ACID stands for atomicity, consistency, isolation, and durability. That's a concept that non-relational databases break up because it's slowing things down. And also we want to have massive amount of operations and not just always have that strong consistency. There's always a trade-off with performance when you have you have to find a different middle ground in this. So that's actually quite a good overview about the SQL relation. So let's do the same thing for non-relational. So I will change my prompt a bit, and now we will look for non-relational database. And just so that I don't get something completely off, I will say, like Azure Cosmos DB. So let's see what kind of characteristics it's bringing back this time. Yeah, 6 ideas again. So let's just move them onto the board and move them up here. Also, a very important topic is where it didn't say this on this side, where with a relational model, a relational database has a fixed schema, meaning it requires a schema for all data in the database, and sometimes it's a little bit of a hassle to change this because it will be changed for everything. With Cosmos DB, you have a flexible schema, which means you can change properties or what kind of properties you would like to have for individual items individually without changing it for all the database items in your Cosmos DB. So it's not saying that it is schema free or doesn't have a schema. It has a schema, but it's flexible, or sometimes also called a fluid schema. Then of course, Cosmos DB supports multiple data models, different APIs. We don't just have that core SQL one, we have MongoDB, we have Table API, Cassandra, and others. And for me as an admin, I can use what I'm already familiar with. I don't have to change the tools I'm using. I might even not have to change any of my code because then I can use the same clients. And then it's of course highly available and durable, which is not necessarily something that you don't find in relational database, but the way that Cosmos DB, for example, is designed is from the get-go already determined to provide that incredibly highly available system and durability. Yeah, and that goes also into the global distribution capabilities, including low latency and throughput. Because if I make my Cosmos DB, for example, in the beginning just available from Germany, because I'm starting a new application and I would like to see how it goes, and it goes very well. And then at some point, I can just easily add additional regions. I can move over to other European regions. I can move to other countries. I can move over to Americas or to Asia. Wherever we have data centers available, you could add an additional replica for your Cosmos DB without deploying servers and so on. And the whole system is built for low latency and high throughput, all backed by the Azure backbone network. And there's so much that we do from a availability perspective with all the different options that we provide with zone support from a hardware and the software side, where we have a big focus on keeping the data not only secure all the time, but also provide you that performance that you require. And with Cosmos DB, the really cool thing about it is that it gets you guaranteed performance and throughput for your data purposes. So some of you might probably already think like, oh, okay, Michael says here, and it is on the whiteboard, so it's non-relational. So yeah, we actually have to put now this in parentheses, because Cosmos DB, since recently, can actually be relational too. And the reason for this is that we added recently to the supported APIs PostgreSQL. And PostgreSQL is the only one that allows us also now to create and handle data in a relational way. But of course, with all the different benefits and the underlying infrastructure and capabilities that I just talked about. So yeah, Cosmos DB can now actually be both. It's a non-relational and relational database if you need it. For all databases, data consistency is key, ensuring that all copies of the data reflect the same state even after a change is made. Global distribution is what Azure Cosmos DB can bring to you, because it can distribute data to any Azure region with just a button and offer multi-region writes and data availability with zero downtime. Did you ever want to have more control over data consistency, to choose the right model for each purpose? Cosmos DB offers 5 consistency models to choose from to give you either the strong consistency or performance depending on the needs of your application. Cosmos DB offers low millisecond response times, automatic and instant scalability, and guaranteed speed at any scale. It also provides a comprehensive suite of SLAs, including industry-leading availability worldwide. Almost all read and write requests are lightning fast, happening in less than 10 milliseconds. Only a 1% fraction of requests might take a bit longer. Independently and elastically scale storage and throughput across any Azure region, even during unpredictable traffic bursts, for unlimited scale worldwide, is what Azure Cosmos DB offers. In this unit, we will describe the elements in an Azure Cosmos DB account and how they are organized, explore the APIs supported in Azure Cosmos DB, and choose the appropriate API for your solution. And we will look at request units, what they are and how they impact the costs. An Azure Cosmos DB account can handle as much data and throughput as you need. You can create one or more databases in your account and then one or more containers to store your data. In Azure Cosmos DB, a database is like a namespace, and it is just a group of containers. An Azure Cosmos DB container is where your data is stored. Instead of scaling up with bigger virtual machines like most relational databases, Azure Cosmos DB scales out. Data is stored on one or more servers called partitions. To add more throughput or storage, more partitions are added automatically. You don't have to interfere. This relationship gives a container an unlimited amount of throughput and storage. Containers don't have a fixed schema. Items in a container can have any schema or different entities if they have the same partition key. Depending on which API you use, individual data entities can represent in many ways: a document in a collection, a row in a table, or a node or edge in a graph. Azure Cosmos DB provides different database APIs such as NoSQL, MongoDB, PostgreSQL, Cassandra, Gremlin, and Table. With these APIs, you can represent real-world data using documents, key value, graph, and column family data models. You are most familiar with Apache Cassandra? Your code is written to interact with it too. No need to change any of this. These APIs let your applications work with Azure Cosmos DB as if it were various other database technologies like Cassandra, without the hassle of management and scaling techniques. Azure Cosmos DB enables you to use the ecosystem's tools and skills you already have for data modeling and querying with its different APIs. All the APIs offer automatic scaling of storage and throughput, flexibility, and performance guarantees. There's no single best API, and you can pick any one of the APIs to build your application. In the next demo, I will show you how to pick an API for your Azure Cosmos DB account. In this video, I will show you how to create an Azure Cosmos DB account and pick the API you want to use in your Cosmos DB instance. So in the Azure portal, I will look for Azure Cosmos DB. It's already here, but I will show you how you can use the search bar here to find this. And there are already different offers available, but let's start with this one, the Azure Cosmos DB from scratch. So I don't have anything around yet, so I will go ahead and create a new Azure Cosmos DB account. If I do this, it comes up with a list of all the available APIs. So now I can choose if I want to do the core one, the NoSQL, or the very new addition here, the PostgreSQL, MongoDB table, Apache Gremlin, or Apache Cassandra. So these are all the different options. Let's say I would like to start with the core version and I use the NoSQL one. And then I create a new account in existing resource group that I have. I provide a name for this instance. Let's say we want this to be a Contoso Cosmos DB Contoso instance that is running in, let's say we just give it a number. Cosmos DB Contoso 1 is good enough. A couple of options here. I don't want to go in all of this, but let's say I pick a region here like East US. I don't want to use availability zones right now. And the capacity mode that I would like to have for this one is provision throughput. Provision throughput allows me to determine the request units that I want the database account to have available for all my containers. And that is then the guaranteed throughput that I get. Serverless would allow me to run my instance in a way that I only pay for whenever I really consume any request units on that kind. I don't want to use the free tier. That's a cool option. If you want to just play around with the Cosmos DB, you can create this for 30 days without any extra cost. That's a really cool option, but of course we don't want to do this right now. Now from here, I go and see if, let's say we don't want to start with geo redundancy right now. Multi-region writes also something I might create a bit later. And then the rest is just the normal configurations like connectivity method. We want it to be available from all networks. The backup policy comes with backup integrated, so I can just let it be backed up every couple of hours or minutes, whatever what I refer here. And also depending on what I select here, I will have a certain number of copies that are retained, and I can even keep this in different redundancy styles. Last thing, encryption. I will use the service managed key, service by Microsoft, and that's it. Tags I don't need, so I will just go ahead and review and create this. And this is how I create a Azure Cosmos DB account and pick the API that I want. Now that I have this API picked, I cannot change it when this instance is created. If I would like to change or have a Cosmos DB with a different API, I would need to create a different instance for this. Azure Cosmos DB charges you for the throughput you set and the storage you use every hour. Throughput must be set to ensure that your Azure Cosmos DB always has enough system resources. Azure Cosmos DB standardizes the cost of all database operations and expresses it by request units, or RUs for short. A request unit represents the system resources such as CPU, the IOPS, and memory that are needed to perform the database operations supported by Azure Cosmos DB. One read of a 1 kilobyte item equals one request unit. All other database operations have a similar cost using RUs. No matter which API you use to interact with your Azure Cosmos DB containers, costs are measured in RUs. Whether the database operation is a write, a point read, a query, costs are measured always in RUs, no matter what. The kind of Azure Cosmos DB account you have affects how the consumed RUs are built. You have three options for creating or respectively configure an account. In the provision throughput mode, you choose the number of RUs for your application in multiples of 100 RUs per second. You can change the provision throughput for your application by adding or subtracting the number of RUs at any time in steps of 100 RUs. You can do this either by code or by using the Azure portal. You pay hourly for the number of RUs per second you set up. By the way, you can set up throughput at two different levels of detail. One is the containers itself and the databases. The serverless mode lets you create resources in your Azure Cosmos DB account without specifying any throughput. You pay for the request units that your database operations use at the end of your billing cycle. And then the auto-scale mode lets you scale the throughput of your database or container based on how much it is used without any delay. This scaling operation doesn't change the availability, latency, throughput, or performance of the workload. This mode works very well for mission-critical workloads that have changing or uncertain traffic patterns and need SLAs on high performance and scale. Where are these RUs visible to us? How can I tell how much RUs have been used? Follow me to the next demo and I'll show you. In this video, I will show you where you can set the request units for your Cosmos DB account or for the containers in it, and how you can tell how much RUs are consumed by a specific query or other operation on your database. So we're looking at an Azure Cosmos DB account. I have already opened this up in the Azure portal, and on the left-hand side, you can see I opened up the Data Explorer. This is this blade, this website here that we see embedded into the portal. In my NoSQL API Cosmos database account, I have two different databases. One is Cosmic Works, the other one is my database, and each of those databases has a container. Now, when I want to check what is the RUs that are currently available for this specific container product, I switch into the Scale and Settings view here. If I click this open, you can see on the right-hand side, here we have 400 RUs per second associated with this specific container. 400 is the minimum, and it's also the default option. And if I find at some point that I need more, I can just change this. So let's say I need or I want to try out with 600, I can just easily create this. But of course, it's hard to understand how much you actually need if that is the first time you're doing this. So what you could use as well is use the capacity calculator. That's a link embedded in the portal right away, but you can also find this as a separate website. So if I open this up, it shows me here a view where I can select the API that I'm using, the number of regions that I would like to use for my Cosmos DB, if I want to have multi-region writes enabled or not. And then you can say how much data will you have stored in your database approximately. And then down here, you can also say how many create, updates, or delete operations you might have in your respective regions. And whatever you enter in here, this will calculate an estimate on the right-hand side what your database configuration will cost you overall per month. So that gives you a good idea of what that will eventually cost. And of course, you can monitor this. How can we do this? Now, I said I have one container with a few items in it. This is a sample database here or a container in a database where we have a couple of different products listed. The data is in here, and I would like to show you just like a normal query. So I will go and create a new query. And then this SQL query here, so it starts off from the normal default option here where it just says select everything from C, which is an alias that we can use for the container that we're currently connected to. It doesn't have to be C, it can be whatever you want. To be, let's say, a little bit more descriptive, I could even say, let's name this with an alias called product. And this alias will be for P, which is just another letter that I choose. I can choose whatever letter I want. C is just the default. P is what I chose because it's short for product at that time. If I execute this query now, it will give me a list of all the different data, right? So the first 100 in here. And but now I want to see how expensive was this. I can check the query stats for this. So you can see that this request actually turned out into 8.37 RUs. And that is quite expensive because I did not have a specific field, for example, determined. So let's try this. Let's go for a specific product name. So I will use normal T-SQL conventions here. So I will want to just have the name right now. Let's execute that query again. And you see, it's a bit less RUs that we have right now. And you can optimize these queries more and more to see that you have the lowest possible amount of RUs, or you just have an estimate on what kind of queries you will have in your day-to-day business, and then also can estimate what that will turn out to be overall. And in here, let's see, I can even do a little bit more complex things where I have a combination of different fields, where I also add in a where clause and say, show me all the products that have a price higher than 200, and all is the same thing here. So because that is a little bit more complex, and we also do some comparison here, we get 11 RUs out of that. So play around with the queries that you have come up that you want to use and find out how expensive they are and if you can optimize them. In this unit, we will learn about the 5 different consistency levels that Azure Cosmos DB provides. I will explain the names and the different characteristics and how you choose the correct one for your project. When data is replicated over a wide area network to different regions in a distributed database system, this can improve availability or reduce read latency for users, but it also requires some compromises. Either the data will not be fully consistent across the database, or the write latency will increase as the data is confirmed to the other regions at the same time. Azure Cosmos DB provides a range of consistency choices with different levels between the usual strong and weak options that other data storage solutions offer. Are you a musical person? Don't worry, you don't have to be to understand this. I will give you the important details. The musical notes represent writes to the West US2 region and how they are read in other regions configured for the Azure Cosmos DB database. With strong consistency, it's guaranteed that each read in any region will always get the latest write. The important fact here is that the write is made available in all regions at the same time and in the correct order, which should be music to your ears. You won't ever get an outdated read with strong consistency, which makes it suitable for situations like transaction processing, such as changing the status of an order. Eventual consistency would very likely hurt your ears, because it's at the opposite side of the range of consistency levels. The notes written in West US2 region will only eventually arrive in the other regions, at different times, not guaranteeing the order. A good scenario to use eventual consistency is when fast loading times is the most important thing. For example, think of a social media post. You don't care much if the number of likes reflects every like from every user at the instant across the world. You just want it to load fast. Now, bounded staleness lets you set a limit on how much lag is allowed. You can think of this as a range within which outdated reads may happen, which you can then specify in terms of either time or a number of operations. Beyond this range, strong consistency is ensured. So the song is coming in the right order, but not at the same time in all the regions. Session consistency is a good choice for most applications. It gives a way of limiting strong consistency to a single session without sacrificing the performance benefits associated with global strong consistency. For example, a user who posts a comment on social media, if the page is reloaded and the user doesn't see their post, that user might do it again and see duplicates at some time. With session consistency, where your own writes are followed by your own reads within a session, you can prevent this. If you can tolerate some delay, but you need to avoid seeing updates in the wrong order, consistent prefix is a good option. For example, a group chat. Imagine Alice and Bob, who else would help us understand the messaging scenario, are planning dinner and saying, what time should we meet? How about 7? I'm busy then. How about 8? That's great, let's meet then. If Carol and Dan, who are they, are also in the group chat and see these messages mixed up, they might show up at the wrong time. With consistent prefix, you can make sure that the messages arrive in the right order, and so will your dinner guests. Hopefully, with the examples I gave you, you have a good enough understanding of when to choose the right consistency level. Microsoft Learn has a lot more examples and context if you need it. Head out there and check the details before you make your decision. You have now uncovered the core features and functionality of Azure Cosmos DB, empowering you to build globally distributed and scalable databases effortlessly. With its multi-model support and flexible scalability options, Azure Cosmos DB enables you to tackle diverse data challenges with ease. Embrace the power of Azure Cosmos DB and revolutionize your data management strategies today. Thanks for watching. Keep on learning.